Hi everyone, and thanks for tuning in to our video titled Solving Systems of Linear Inequalities by Graphing. So what's interesting about this is we've already graphed single linear inequalities. In a previous unit, we learned how to graph something like the top inequality here in this system. Today, what we're going to do is put more than one linear inequality together to form a system. So you may want to grab, like I have here, some colored pencils or maybe some different colored pens, something that you like to work with, because what's easier with these graphs is to use color and to color code things. Okay, so let's take a look at example 1. It says graph the system, and here it is. 3x plus 2y is less than or equal to 6, along with 2x minus 5y is greater than or equal to 10. Now, both of these equations are in standard form, and when it comes to graphing, I don't particularly like graphing from standard form. I prefer slope-intercept form. So off to the side, I'm actually going to recopy these two inequalities so that I can work on them to get them into slope-intercept form. So there's my first one, 3x plus 2y is less than or equal to 6, and then I'll kind of draw a separation here. And then I'll copy down the other one. 2x minus 5y is greater than or equal to 10. Okay, so let's start working on this first one. So from our previous studies, we certainly know to subtract 3x from both sides. So that's how I'll start. That's going to cancel my 3x's out on the left side of the inequality. And I will bring down 2y is less than or equal to, and on this side, I'll write this as negative 3x plus 6. Sorry, I'm kind of bleeding over here. Negative 3x plus 6. And then I'm going to divide every term of the inequality by 2 so that I have y alone. So we're going to have y is less than or equal to negative 3 over 2x plus 6 divided by 2 is 3. Now here's where the color coding is going to come in. So I'm going to take my, looks like purple, my purple colored pencil, and I'm going to like box this in with purple so that I know when I go over here to my graph, this one's going to be in purple. So let's go ahead and graph this one. So we graph inequalities much the same as we graph lines, and we just tag on a few extra steps at the end. So we know that this graph is going to have a y-intercept back here. Here's my b value. B is the y-intercept of the line, so positive 3. So starting from the origin, I'm going to go up 3 units to my y-intercept. From there, I analyze the m, or the slope, and I can see that it's a negative slope. So my line's going to be coming down from left to right, and I'm going to be going down 3, right 2. So from here, down 3 and right 2. And I'm going to keep doing that as long as I can. 1, 2, 3, 1, 2. Down 3 and right 2. And if I go the opposite way, I would be going up 3 and left 2. So those dots form a nice line. Now, I have to check if my line is solid or dashed. So I look at my inequality symbol. It says y is less than or equal to. So I definitely want to include in my solution set all the points on the line. So I'm going to make that solid. So I'll grab my ruler. Let's make that solid line. Beautiful. And then the last piece of this, if you remember from our previous learning, is to shade one side of the line. So here's our divider. The line kind of creates a boundary. You either shade this side of the line or you shade this side of the line. It's one or the other. It's a 50-50 chance you take here. So the way I taught it earlier is you really have to look at the symbol, less than or equal to. I like to put my pencil point on the y-intercept. Boom. See how I'm on the y-intercept? This is the y-axis. Here I am, y-intercept, y-axis. Now, my y's are less than the line. Less than. So if I went up, my y's would be getting greater. But if I go down, my y's are less. So now look at which side of the line I'm on. I'm not on this side of the line. Look at where that arrow is. It's on this side of the line. So because this arrow pushes less than, I'm going to lightly color this side. Very lightly. Less than, down. Okay. Now, one of my students this year, I'll give him credit, Kevin, you know who you are, he came up with a little trick for this. He told us, okay, take your inequality and write it sideways going up your paper. So if you were to write this inequality sideways going up the paper, it would look like this. And his trick was, now look at your symbol. Do you see how the arrow is pointing down? So we go down under the line. So this right here matches what I drew here, and it takes you to this side of the line. Isn't that cool? Okay, now that's where we stopped when we did this previously, but today we have another one to add. So what we need to do first and foremost is take this standard form and let's change it into slope-intercept. So same idea here. I'm going to start by subtracting 2x from both sides. That's going to leave me with negative 5y, don't lose the negative, is greater than or equal to negative 2x plus 10. Okay, now I'm going to divide everything by negative 5. Now, hopefully, you remember the rule that says when you divide by a negative in an inequality, you must flip your inequality symbol 180 degrees. So I divided by a negative 5, so I'm going to turn that around to less than or equal to, and then finish it off. Negative 2 divided by negative 5 is a positive 2/5 x, and a 10 divided by a negative 5 is a minus 2. So now I need a new color. I'm going to go with green, my favorite color. I'm going to kind of box this in with green. Okay, and I'm going to start, just like I did on my last graph, with the y-intercept. So let's check out B. Our B value is negative 2. So on the y-axis, I'm going to come down to, in green, to my y-intercept. Now my slope, my m, is positive. So I'm going to rise 2, 1, 2, and run 5. 1, 2, 3, 4, 5. I don't have any more room on the right side, but I could also go down 2 and left 5. 1, 2, 3, 4, 5. Okay. I'm going to check out my symbol. It does say less than or equal to, equal to, equal to. So I'm going to make the line solid, just like the purple. Draw my solid line here. And I am going to look at my symbol. Now, symbol says less than. So I'm going to put my pencil point on my y-intercept. Now, with regard to the y, if I went up, it would be greater. If I went down, it would be less. So here's my boundary, right? Greater would be this side. Less would be this side, the side that this arrow's on. So if I lightly color this side of the line, I'm going to be down here. And you can see, even if I use Kevin's little trick and write it sideways, y is less than or equal to 2/5 x minus 2. You can see if you look here, down. The arrow points down, my green arrow points down, and I colored this side of the line. Now, the final solution. Okay, so what does this all mean? Well, where the purple meets the green, that is the solution. That's the final answer or the solution of the system. So I'm going to grab a red now, a red colored pencil, and I'm going to color in darkly the final solution. So if you look around, here we have no shading. Here we have just purple. Here we have just green. But right down here in this lower region, you can see where the purple and the green collide. That is going to be my final answer. Actually, in a few more days, we're going to actually be calling this the feasible region. It's where like all the constraints come together. These are the constraints where all the constraints align. This is your feasible region. This is what makes sense in the problem. And what's really cool is you can totally check this. So if you would pick a point in this red area and plug it into these two inequalities up here, it should be true. So let's do something. Let's pick a point. You can pick your own or you can work with me. I love to work with 0 when it's possible. So to me, why don't we just use a point like 0 and then 1, 2, 3, 4. Why don't we use 0, -4? This will be the test point, so to speak. So 0, -4 lies in the feasible region. So this is going to be my x and my y. And I'm going to go ahead back up to my original equations and put that in. So if I use my first equation, so this would be my check. I have 3x, so 3 times 0 plus 2 times the y, which is -4, should be less than or equal to 6. Well, let's see if it is. 3 times 0 is 0, so that just kind of goes away. 2 times -4 is -8. So -8 is less than or equal to 6. That is true. So that's a good sign. Now let's test our second inequality, 2x. So 2 times 0 minus 5 times -4 should be greater than or equal to 10. So 2 times 0 goes away. -5 times -4, positive 20, greater than or equal to 10. That is also true. So that's also a great sign. So points in this red area seem to be working. If you had chosen a point on this area, the purple, it would have only made the purple inequality true, and it would have made the green false. If you would have chosen a point in the green section, it would be the exact opposite. Green would be true, purple would be false. If you chose a point up here where there's no shading at all, neither of these would be true. So this is how you do it. All right, we have one more example. So head down to example 2 on your note sheet. It says graph the system, but this time there are actually 3 inequalities in the system, and that's fine. We can do 3. I'm just going to need another colored pencil. So let's start with the first one. In standard form, we've got 3x minus 4y is greater than 8. So let's just work on getting this into slope-intercept form. So just like before, we're going to subtract the 3x from both sides and cancel those out. Bring down the -4y greater than -3x plus 8. We're going to divide each term by -4 to isolate y. And we have to remember that when you divide by a negative, you have to flip your inequality symbol, so greater than becomes less than. The negative divided by the negative becomes positive. And then the 8 divided by -4, -2. Okay, so let's go with purple again for this one. Start with purple. And let's go ahead and graph it. So we're going to start with our b, -2, y-intercept. So let's come down to on the y-axis. Then we cruise over to our slope, 3/4. So we're going to rise 3 and run 4. And I don't have enough room to do that again, so I'll go the opposite way. Down 3, left 4. Okay, look at the symbol. Less than. It does not have the equal to with it. Therefore, we are not including the points on the line in our solution. And so we will dash this line to show that we are not including the line as part of the solution or feasible region. So those on. Now, back to the symbol, less than. Put your pencil point on the y-intercept. Here's your y-axis. If you went higher up on the y-axis, you would be getting greater. Y would be getting greater. And if you go down the y-axis, you'd be getting less. And so this, when you're comparing this side of the line to this side of the line, this arrow, less than, sits on this side of the line. So this is where we want to lightly shade. If you were using Kevin's little trick, write this sideways. Y is less than 3/4x minus 2. And you can see that this arrow is pointing down, as is this. Okay, now you'll be happy to know that the next two inequalities, there's nothing to do to solve them. I'm just going to write them in the colors I'm going to graph them in. So y is greater than or equal to 1. Hopefully you remember what kind of a line this is. You can pause this video to think about it if you need to. This line, because it has a y and no x, is horizontal. Okay, this is a horizontal line. And where do you draw it? Well, you go to y equals 1. So come up to y equals 1, put a dot, and we're going to draw a solid equal to, solid horizontal line through there. And we are going to put our pencil point on the y-intercept, which is right here. Look at the symbol. Y is getting greater. Y greater would be up. If I wrote sideways, y is greater than or equal to 1. You can see that the arrow is pointing up, just like this. So I'm going to lightly shade green up here. Okay, and then last but not least, I'll go to red. We have our final inequality, x is greater than 4. And x is greater than 4 is another special kind of line because it has no y, just x and a constant. That's a vertical line. Where? Well, you go to x equals 4, right here. And you draw a vertical line through here, but it's going to be dashed because the greater than does not have an equal to with it. So we will dash this line through here. And where will we shade? Well, now x is getting greater. So with regard to the x-axis, I want you to put your pencil point on 4 on the x-axis. If I go to the right, the x's are getting greater. If I go to the left, the x's are getting less. Well, I want to go greater, and look at where that arrow is pointing, to the right, so I want to go this way. So if I lightly shade in red, all the way over here, we have it. Now this just looks like a child drew on this. It's like a mess. You have to find where the three colors merge and come together. So here I'm only seeing green. Here I'm seeing nothing. I see only purple. I see only red. Right here I see like red and green. But the place where I see all three colors is right here. It almost looks like it's in this little triangle area here. So I'm going to say my feasible region, because it's got to be to the right of the red, above the green, and under the purple. So that's going to put me right in this feasible area right here. So hopefully you kept your drawing nice enough that you can see that. Whew, okay, so that is how you graph, look at that. So that is how you graph a system of linear inequalities. So thanks for tuning in, and we'll see you next time.